My cousin requested me to build him an amplifier, so let's build him one. The heart of the circuit is a TDA2003 10-watt audio amplifier driving a 8-ohm 10-watt speaker. Let's start with the explanation of the schematic. Most of what you see here has been directly pulled out of the datasheet with few minor additions. Firstly, the left and right audio signals are converted into a mono signal using two 1 kΩ resistors. The 4.7K resistor gets rid of unwanted 50 or 60 Hz hum which the aux cable may pick up when left floating. The 10 microfarad capacitor gets rid of any DC offset in the audio signal, also known as the input DC decoupling capacitor. C7 and C3 are power supply filtering capacitors. For the best performance, it is recommended to place C3 as close to the power pins of the IC as possible. Resistors R1 and R2 set the gain of the amplifier. Since this is a non-inverting amplifier, the formula to calculate the gain is this. Feel free to muck around with the values, but I stick to the recommendations of the manufacturer. Using values lower than the recommended ones will increase the drain current. C6 and R4 together form a low-pass filter, whose job is to allow frequencies beneath a certain value to pass through, while frequencies higher than that gets diminished. This is the formula to calculate the value of C6. As for R4, the datasheet recommends a value of 20 times R2. C2 is a ripple rejection capacitor, whose job is to reject noise from the power rails and prevent it from entering the feedback circuit. Using lower values will worsen its ability to reject ripples. C4, also known as an output coupling capacitor, gets rid of the DC offset on the signal. Using high values result in better low frequency performance. 1000 microfarad is a good balance between capacity and performance. Lastly, C5 and C3 provides frequency stability and prevents oscillation, especially when driving inductive loads like speakers. Next, I laid out all the components on the perf board. When doing so, there are a few design rules that must be kept in mind. At higher currents, the speaker might inject noise into the circuit. This will be fed back into the inputs of the amplifier. The amplifier is then going to amplify it and represent it at the output. To overcome such problems, a star ground is used, wherein the ground of the amplifier, the audio signal, the feedback resistors, as well as the 4.7K resistor must all be connected at a common point, also known as a star ground. And finally, the boring theory is over. Well, now let's proceed with the fun part, the soldering process. After around 30 minutes of soldering, the PCB was complete. A heatsink must also be added. It doesn't need to be beefy as the power consumption stays stagnant around 1 watt. Moving on to the case construction. Wooden boxes are better, but plastic boxes are definitely cheaper. I started by creating a cutout for the speaker, then for the female barrel port, and at last for the heatsink and the aux cable. At last, I used super glue and hot glue to secure everything in place. To cover up the super glue stains, the front and the rear were painted black. Finally, the project is complete, and it sounds awesome as long as the amplitude is kept below clipping point. Well, let's test it out now.
Ever young, ever strong, ever bright.